Hello guys! Hello everybody! Welcome to my YT channel. This is again, I am a senior internal voice, engineer Sotero Jr., occupational safety health engineer, and a chemical engineer by profession. Welcome to my YT channel. Okay, it's been a long time, right? I did not do my vlog and live stream. And let's come back. Let's solve problems of physical chemistry and thermodynamics. Okay, especially to those chemical engineering who will be facing the chemical engineering board examination administered by Philippine Regulation Commission PRC this October 2021. So please stay tuned with me because I'll be able to give you some tips of problem solving and some theories, concepts, although and principles regarding pure sciences, especially physical and chemical principles, and a little bit of chemical engineering. Not the major one, but at least it is the basic foundation of chemical engineering. Okay, so we have three areas in the PRC board examination. We have the general engineering composed of different mathematics, okay, algebra, trigonometry, geometry, probability and statistics, the calculus, the differential and integral calculus, the differential equations, the advanced engineering mathematics, right? So those are the subjects belongs to the general engineering. And in the physical chemistry, in the day two, I think, day two or day three. In the physical and chemical principles, we have a lot of subjects there composed of mainly chemistry, okay, physics, organic chemistry. It's gonna be physical chemistry is also considered there. Physical chemistry, and I think so. No, thermodynamics, I think so. But in chemical engineering, there's a lot. The unit processes, the chemical, the chemical process in industries, the industrial control processes. We have also the unit operations. Okay, the unit operations composed of unit operations one, unit operations two, unit operations three, and we have to break it up. We have the chemical separation processes. We have the transport phenomena, momentum transfer, heat transfer, like that, and mass transfer. And we have also the screening. Remember that one? Leaching, flotation, humidification, okay, like that. And we have also crystallization, drying. We have fluid flow, fluid dynamics, fluid mechanics. Okay, what else? And a whole lot more. Okay, so all you have to do is to practice problems, okay, to solve. And then before going to solve problems, you'll be able to go to the theories and concepts in the introduction on the books. Topic by topic, there's an introduction, right? You'll be able to absorb the theories there before going to the problem solving. Okay, something like that, and go to the most easiest problems rather than going to the most difficult part. Okay, because in the board examinations, not all difficult will be coming out. Okay, it's just easy, average, a little bit difficult, something like that. Okay, if you try to weigh the degree or the leveling is not that difficult as what we think. Okay, so let's proceed now, solving problems. But before that, this problems mainly focusing on the behavior of ideal gases and non-ideal gases. Okay, something like that. You have also to apply the first law of thermodynamics, the second law of thermodynamics, and also the law of conservation of energy, okay, something like that, the law of conservation of matter, the law of conservation of what? Mass, right? Okay, something like that. So I have here one problem. This is very easy. You don't have to worry because this is not a difficult problem. Okay, this is not a difficult problem. This is very easy to solve. Okay, I'll give you 2 to 5 minutes to read the problem. Okay, zone in, okay, like that, okay, okay. Now you will be able to determine the data, the given, what is being asked in the problem, and then what are the particular specific or appropriate equations and formulas to be used for this problem. Okay, our timer starts now. Okay. Heating 1 mole of an atomic ideal gas at a constant volume from 288 Kelvin to 300 Kelvin. Determine the heat absorbed to the system and how much change in internal energy for the process. So, okay, heat energy is being asked, the heat absorbed to the system. Meaning to say, our heat energy here is positive. It's not negative. Okay, it's not done by the system. Okay, number two, the internal energy of the process. Okay, something like that. So we don't know yet if it is really a spontaneous process or non-spontaneous process in this question. Okay, let's solve now. Okay, like that. Okay, so please be reminded that we have at least 12 or 12 to 14 equations and formulas of gases problem solvings, or shall we call that as gas stoichiometric problems, all involving gases problem solvings in chemical engineering is having 12 to 14 equations. Okay, mainly for gases only, huh? Not for incompressible fluid or incompressible liquid. Okay, okay, because of the fact that gases have a high viscosity, okay, high viscosity and have a higher diffusion rate compared to the liquid. Okay, liquid needs a lot of kinetic energy. Okay, so that those molecules will be bombarded with each other and then it will resolve to having a high intermolecular forces and then eventually it will escape to the air. So in gases, we need to apply more heat for that because the distance of each molecule are quite far with each other. That's why in most cases, intermolecular forces is not yet considered. And although there will be no pressure fraction and volume fraction because these gases occupy a volume, measurable volume. Okay? Sorry, unmeasurable volume. Baliktad. Because measurable volume is non-ideal gas man siya. Okay? If, if a measurable volume, meaning to say, it is not counted, right? English. Okay? But if it is measurable, meaning to say you have to account, right? Okay? And then if it is immeasurable, meaning if you cannot measure, then what's the reason of accounting that one? It's gonna be like that, okay? So that's the principle behind, okay? Like that. Oh my gosh, it's very hard to open this. What's this? Oh my gosh. Sorry guys, wait for a while. I have to open this. Oh my gosh. Okay. Wait ha! Mga friends. Oh. Oh my gosh. Hello guys, hello class. Welcome back to my CHE diary, chemical engineering diary. Okay. So because I am in the OSH field and it sounds to be, for me, it sounds to be boring. That you keep on repeating what you do in a day. And I want to become a challenge, okay, to be challenging at all times. So, of course, since I am an engineer, I have to share information, technical information, or academic information regarding the subjects of chemical engineering, but not all. I must choose only to those subjects that I excel the most. Okay, but for the difficult, I can no longer discuss with you with that. I cannot promise. We will try. Okay, because as a student, before, okay, we have subjects that we don't like. I mean, okay, we have also subjects that we like. And then we force ourselves to study because we need to have a good grades and we need to pass the grades because our parents are paying money and tuition fees in order for us to obtain our education, our college education. Okay, and for others also, for others that are scholars like me, okay, I have to maintain grades also being an academic scholar, right? So it's not that easy to become an academic scholar. You have to maintain grades. Okay, and you have to be eliminated and rejected from the scholarship if you will not maintain grades. Okay, that's clear. And then advice to all first year chemical engineering students of Cebu Institute of Technology University and University of San Carlos, because there are only two schools and universities offered BS Chemical Engineering in the entire Cebu. Okay, I don't know whether UP Cebu, University of the Philippines Cebu, they don't have, but they have environmental, no, Masters of Environmental Science. Okay, and BS Biology. The sciences are not really that chemical engineering, whatever, chupa chuchu. Okay, there are only two schools in Cebu offered chemical engineering curriculum. Okay, so I advise you not to do chica chica in your free time. You focus on your studies and then go to the library always. Okay, every vacant, go to the library and explore the world of pure sciences in combination of mathematics and of course chemical engineering. Okay, it's gonna be like that because engineering are full of mathematics. Okay, even though you are not good in mathematics like me, but you can develop that if you have the culture and habit to study the subject by heart. Okay, that's very clear. If you study that subject by heart, even though you don't like it, or even though you are weak in that particular subject, then you can pass that subject because you have effort and very serious and focused to that particular subject. Okay? And it's not true that you will never become an engineer if you are not good in mathematics. Okay? Really, really not true. 101%. Okay, all you have to do is to have an adequate, thorough preparation in the upcoming examinations so that you can maintain your grades well. And then, as what I said earlier, you have to be resourceful, initiative in going to the library, solve some problems, read a lot of views on concepts and principles so that you can understand really what's going on with a particular subject or topic to topic. And then in my part before, I have to consult higher engineering student that will be able to teach me why it become like that. Okay, you have to share information. You'll not be afraid to ask help from them. Okay, that you have to be uh, approach them in your free time also. Okay, like and bring books. In my part before, I bring at least 3 books in my home, daily ala tool. Okay, or it's gonna be 4 books. Okay, and then during my free time, I am in the library always. I don't go to the whatever places there in Cologne. I'll never taste that. I'll never experience that in my entire college days in Cebu Institute of Technology. I'm just focusing on my studies in my BS Chemical Engineering course. Okay, that's why it really reaped me a good fruit and harvest after I taught the BS Chemical Engineering for examination. Okay, because aside from the stock knowledge, aside from the academic information, your efforts matter the most. Okay, the length of your preparation, adequate and thorough preparation, matters the most. And you should be a wide reader. Wide reader, meaning to say you read every day, read books, any kinds of books, any encyclopedias pertaining to your course. If you cannot understand, okay, do not rely mainly on the instructors and your mentors in the school because they are just only sharing what they got when they are still students. Okay, it should not be imparted some or all of the topics. Okay, then you have to have your own uh, exploration regarding your course. Okay, something like that. So too much chica chica, go directly to the point. Okay, our given here is only temperature. Do not be afraid. Okay, my weaknesses before when I was also in college. Okay, though really my aim is to become a top notcher. Really, I don't have to hide. I don't have to be an arrogant. I have to be honest. I really want to become a top notcher. Okay, when I plan to talk about when I plan to take a for examination. Okay, so the temperature is given. Okay, but you should take note class in this situation. Do not be afraid if there is only one given, because the formulas have so many variables there. Right? And, oh my God, what's that? Only one given. How can I find the others? You will ask yourself. Okay, then you connect all the theories and principles that you've studied. Okay, and then you can connect that there. Okay, and that's the time assumptions come in, scientific assumption. What is example of an assumption? For example, let's consider this as an equilibrium stage. Equilibrium state for point 1 is equal to point 2. Let's assume thermodynamic process. So you don't have to wear in the volume. It's gonna be like that. Okay, you do not force everything to be in the formula. Where in fact we have a lot of scientific assumptions derived by the theories and principles and concepts of pure sciences. Okay, something like that. Do not be afraid. And you can also create your own formula as much as you could. You can derive, okay, even though it is not yet discussed in the college education, that you can have your own somewhere along the way in the actual examination. You can connect the dots. Okay, something like that. If you memorize a lot of formulas and equations, okay, because there are a lot of quantities are in parallel with each other, assuming our scientific assumptions valid and will meet. Okay, will meet the criteria has been met, then bingo, we can derive another equation out of those several formulas and equations. Okay, now here, hitting one mole of monatomic ideal gas. So it's in your mind that there is one mole. Okay, mole is a unit of a substance. Okay, that is a unit of a substance or unit of an amount of a substance is a mole, M-O-L-E. If the problem states mole, that is automatically one mole. Okay, if it doesn't specify a figure, then bingo, that could be treated as one mole. Okay, I will put here one mole. Okay, it's gonna be like that class, huh? One mole of monoatomic ideal gas. So we are very, very happy because the ideal gas is not mentioned. You don't have to put chemical reactions out of this. Okay, because this is general. We don't know this gas is. Okay, but we need to compute in this type of gas that is not mentioned how does it behave ideally, right? So one mole of monoatomic ideal gas. Okay, we don't know yet. So I'll just put this as X, one mole of X, right? Because we don't know yet. We know only that this is a monoatomic ideal gas. Okay, now, since this is an ideal gas, you come up to your mind those 12 to 14 equations as pure gas equations on ideal gases. 14 to, oh, tagsa-tagsaon na to ni mo siya if it is appropriate in this particular problem. Okay. So, oh my gosh, ideal gas. So I must start first with PV and RT. Okay, P pressure times volume equals to the number of moles and the universal gas constant times capital T. Guys, capital T is Kelvin unless specified. Okay, but if it is a delta change in temperature, that could usually having a unit of degrees Celsius. But if capital T, that is Kelvin, then if the problem has degrees Celsius given it a problem, then add 273.15 and then it will become Kelvin. Okay, it's gonna be like that. So 298 to 300 Kelvin. So this is a state function because it refers to a state, initial state, final state. Okay, initial stage, final stage. Okay, like that. Okay, so initial from English, from meaning initial. You don't have to reverse that one. Okay, to is final. Again, English preposition. Okay, from initial to final. Okay, so from initial is 298 Kelvin. So I have to put, let's ask T I. I represents initial, the first letter of initial. That's why capital T I subscript. Okay, T I. Okay, ganon. So 298 Kelvin. Okay. To 300 Kelvin. So that is our final temperature, capital T subscript F. Okay, 300 Kelvin. Okay, it's very clear class, huh? Okay, any questions so far? You can ask me through this virtual communication through interactive discussion regarding physical chemistry in combination of thermodynamics as pure sciences in chemical engineering. Okay, if you are interested to ask question, then ask question, or you can leave also message in my FB Messenger, or you can comment down below in the comment section of my YT channel. Okay, and you can chat me also in my chat screen, beside the screen. Okay, going back, determining the heat absorbed to the system. Heat absorbed is Q positive, right? Okay, Q positive. Okay. And then how much change in internal energy? So we don't know yet if it is spontaneous or non-spontaneous. Okay. So claro ba siya, it's a mixture of physical chemistry and thermodynamics because it refers to heat energy and thermodynamics always focus on thermal energy. Okay, like that. And physical chemistry focus on physics plus chemistry plus an application of mathematics. Okay, that's the coverage of physical chemistry. Okay, going. Okay, I have to get another scratch papers. No scratch papers, gonna blank sheet paper in order for us to solve for that. Hello, guys. I'm coming back. Okay. Now, equation number one. Okay, so equation number one. Okay, question number one, PV in RT, since we first used this because it was mentioned that this is an ideal gas. Okay? Okay. Now, take note at a constant volume. At a constant volume. So what comes in our mind? This is an isovolumetric thermodynamic process or the isochoric thermodynamic process. Isochoric and isovolumetric is just similar in technical definition in science. Okay? If that isochoric is equal to isovolumetric. For example, in the examinations in the future, blank is similar to isovolumetric process. D adiabatic, A E isochoric. Your answer will be isochoric, but because that is a thermodynamic process that is a constant volume, that is theory and concept. Because some problems also will not stay at a constant volume. It will never state that. You will just say, heating one mole of monatomic ideal gas at an isochoric process from two. And then if you don't put that technical information, then you will get lost. You understand? It's not all the time when we say at a constant temperature, at a constant volume. Sometimes we use the technical term adiabatically compressed to, isothermically compressed to, because gases are highly compressible compared to liquid. Okay, because liquid are incompressible, and these gases are compressible. Okay, so meaning to say, these gases are non-Newtonian fluid. Okay, these liquids are Newtonian fluid. Okay, another information, Okay, something like that. So PV in RT, the constant volume. Oh, we cannot force to use this PV in RT because the equation there is volume, and the volume is constant. Remember. So kaliwali, reject this equation. Now we go to the first law of thermodynamics. What is the first law? The first law of thermodynamics states that the law of conservation of energy, that energy can neither be created nor can be destroyed, but it can only be transformed to various types of energies. It could be a kinetic energy, potential energy, chemical energy, mechanical energy, electrical energy, acoustic energy, radiation energy, pneumatic energy, hydrothermal energy, geothermal energy, okay, radiant heat energy of the sun, and others. And there's a lot of energies around us because without energies we cannot survive in this planet Earth. Okay, now delta U, what is the formula of delta U meaning internal energy, the change in internal energy. First law of thermodynamics. Okay, because this is involving the internal energy. Okay, so it's gonna be like that. So the heat energy or the total heat content, okay, in the system. Okay. My gosh. Wait for a while. Okay. So Q, I just say capital Q. Capital Q is equal to the change in internal energy, okay, plus the work. So technically, work, internal energy, and heat are all energies. These are the energies referred to the first law of thermodynamics. But later we will be touching a little bit of enthalpy, but later. Okay. So Q is equal to delta U plus W. Now, so you have Q formula, right? Q nakatong bunog guys siya nga formula na ginagamit sa mga chemical engineering students or engineering students. Q is equals to MC delta T. Gas-gas na rin siya nga formula. Okay, MC delta T. Okay? Or let's say MCP delta T. Okay, like that. Guys, you should take note the subscript because this is very, very important. So I can say this is shown that the subscript is very important here. The CP, the CV, and the C. You get the point? C is a specific heat capacity. Okay. CP is a specific heat capacity at a constant pressure. Okay. CV, okay, specific heat capacity at a constant volume. Now, bingo. In our problem, at a constant volume, so we will use the specific heat capacity at a constant volume, which is equal to C, capital C, subscript, small letter V, CV. Come on, not CP, because they're all formula. I shall write also here is equals to MC. T, I can also say Q is also MCV delta T. Okay, this is gonna be like this. When you discuss about this, you have to stress out to students the difference. Okay, so that we as students, we will not be confused to go to the library. Okay, so it would be better to feed them the adequate academic information about all things. Okay, though it is time to discuss to the most, to the most systematized manner, so that students can understand really definitions there. That you cannot just insert this CP thing. You have to determine the theoretical and scientific assumption. Like this problem, okay? Monoatomic gas at a constant volume. I cannot use the Q is equal to MCP delta T because CP at a constant pressure. Okay, I cannot use also MC delta T because C is the specific heat capacity, whether it is a constant volume, constant pressure, constant temperature, like that. I can use the CV delta T because CV is a specific heat capacity at a constant volume, right? It's gonna be like that. Differentiation matters a lot. The difference of each quantity must be discussed properly to the students. Okay, the content, the importance of content must be discussed with the students properly so that they can really understand what it's all about. Okay, some of them will learn also because their mind also are a little bit empty, especially if the subject is first time for them. At least they will be fed by, systematized information in their brain cells. Okay, ganon. Okay, so, okay, now, if CV, what is the value of CV based on chemistry in high school? Okay. You should remember also in high school, CV, because we are discussing also specific heat capacity in high school. Okay. The value of CV is equals to 3 halves R. Okay. 3 halves R. And the value of CP, specific heat capacity at constant pressure, is 5 halves R. Memorize. Why? Because R has a value. And if you times that with 3 halves, then bingo, you can have your CP. Understand? If you don't know that one, then you cannot answer the heat problem, especially in this kind of problem. Do not rely that it should be put all the time in the problem, and do not rely also in the handbook because you scanning in that handbook at a certain temperature, pressures, and concentrations are very lengthy. So many there, organic liquids, and it will take time for you during the actual examination. All you have to do is to memorize that CV is equal to 3 halves times R, and R is a universal gas constant. Okay, CP is equal to 5 over 2 times R. R is a universal gas constant, and you should memorize those value of R. Okay, so first year pa lang sa chemical engineering, you will memorize all these stuff, guys. Okay, if you really want to pass the BS Chemical Engineering Board examination. Okay, target your plan in the starting point. Yes, it's gonna be like that. Not to be arrogant, I do that in my college education. In my first year, in one first day of my schooling, I really target to become a licensed chemical engineer in the future. Okay, that's why I really tried my very, very best to focus on study during my vacant time. I avoided chicas. I don't watch TV series or whatever movies in the Cologne or whatever. My friends go there, I would just rather stay in the campus of CIT rather than going to this because I don't have also enough money. Okay, why should I go there? Ang akong bound sa Jude. Okay, because we belong to the poverty level and I'm just only in a scholarship. Okay, so I'm not really funded fully by my parents in my education. So I should strive hard. Okay, like that. Though I like, but I don't have money also, then what should I do? Go there. Okay, instead, I will just study in my vacant time in the library or do my assignments, something like that. Pero may gusto malibre ko kopya may atong meat rolls snacks because I used to give my answers also in my assignments, sharing with my, colleagues before. Okay, then ilang makumpas na kun. Okay, something like that. Okay, you need to be smart enough to focus, or shall I say, budget your time lang if you really want to become, because some students are extrovert. Extrovert meaning outgoing person there to do billiard, to do singing, to do drinking of alcoholic beverages, to do chica chica, to do chismes, okay, and to watch movies, cinema, okay, in the cities. But me is the reverse. I am introvert. Okay, I don't love in going too much outside. Okay, so I would rather focus on my study rather than going outside. Okay, that's maybe. Okay, so it's gonna be like because personality also matters. If you are really extrovert enough, then your time studying will be lesser. Okay, because you could not have time to read your books, to read your notebooks, and especially if you are having an early jowa, okay, early relationship, then it can also sometimes ruin your focus on your study. Okay. Though it depends upon the time management of every individual, but if you are taking a course that is highly complicated, then you will suffer a lot. Okay, because really, Bachelor of Science in Chemical Engineering really requires focus and critical thinking subjects. Critical thinking. And apart from that, you should have a wild imagination. A wild imagination beyond what is being discussed. You have to dig it out, something like that, in the deep, okay, not only in the superficial or surface. You will say by yourself, why like this? Why I should go? Why like this? Why like? And if you cannot have the answer, then you go to the library and get 3 to 4 books and facts and compare the presentation of the discussion. Just like me now, I will not rely on one source as in Facebook and YouTube. When I read some news or any information about vaccine or whatever, I shall refer to other sources also because I want to really to have the comparison, a comparative study. Who among them are telling that this is just a destructive statement or a conspiracy to this particular vaccines or whatever, choo. Then you have to research, read, and do not depend on only one source of information. Especially now, I have 2 day offs, Friday and Saturday, then I can really explore my time. Okay, so it's gonna be like that. Going back. Oh my gosh. So, guys, if this is like this, Q is equals to mCp delta T. Q is equals to mc delta T. Q is equals to mCv delta T. We have also Q is equals to mCp delta T. Q is equals to mCv delta T. Q is equals to mCv delta T. And M is the number of moles. Why? Why the formulas changes? Then you have to investigate why the formulas changes. Okay, it's not enough to memorize. You have to investigate. Oh, why there's a changes in these formulas? All I know before is only this, and there's an additional formulas like this. So why? Okay, why is the most intelligent question. If you can answer the why, then bingo, you can understand. Okay, why and how is the most important questions. Okay, not the what. Okay, where and when. It's always why and how. Because how it answers how to do that. Okay, action verb. So that you can understand the particular problem or whatever things you are going to learn. Okay, something like so in CP, delta T. Okay, why? Because guys, this matters also to the specific heat capacity. Sometimes the specific heat capacity expressed ng good siya with kilogram in the denominator. That's why you are having Q is equal to mCp delta T. But if we have a molar heat, specific heat capacity, that's the time we will multiply the Q is equal to NCP delta T, NCV delta T, NC delta T. That's the reason behind. Because not all specific heat capacity is expressed and presented in a problem solving that has a denominator of kilogram only. Sometimes it will vary. They will put the specific heat capacity as kilojoules per mole degree Celsius, not the kilogram. Okay? But take note, in problem solving also, they will never say molar. Okay? Again, the students will be confused because we are used to understand only specific heat capacity. And we also used to understand that the specific heat capacity is always like that, joules per kilogram degree Celsius. But there is another unit expressed also in the same way in the problem solving. For example, heating 1 mole of a monatomic ideal with a specific heat capacity of 2 joules mole per Kelvin. Now that is molar. Supposedly, if If I will help the students, I will create the problem to be like this. Heating 1 mole of an atomic ideal with a molar specific capacity, because the molar word is an identification that there is a mole in your denominator. But sad to say, it's not like that. They will never mention that it is a molar specific capacity. All you have to do is the unit presented. You can understand, oh, bingo, that is the molar specific capacity, even though there is no molar in the problem solving presented. Okay, that's the technique. Okay, focus on the unit, because do not rely on the words, because the words sometimes are not complete. Okay, just like I always keep this repeating over and over again, just like solubility. Solubility is just a concentration, but sometimes they will use that in the topic of normality also. Like that. Okay, then the students will say, what's solubility? Solubility can either be normality, wala. You will use the Henry's constant, right? But in the Henry's law, it is not stated as concentration all the time in the discussion. It is always solubility in the words that come out from the teacher. And if it will change na in the problem, instead the student now will be confused what to apply, because there's a lot of chemistry problems related or similar to that. Okay, so marong na siya. Okay, that's actually, that is gases, that is Henry's law. So even though that is presented concentration, that is also solubility. Okay, because in Henry's law, solubility, okay, is directly proportional to the partial pressure is equal to solubility 2 over solubility 1, as the words and terminology. Okay, so in short, English also is an advantage. Okay, English communication, because solubility and concentration is similar. Okay, meaning synonymous in terminologies. Okay, can be used interchangeably. Okay, since you are only used to that word concentration, and then if there's a replacement of another word that have the same meaning, especially problem solving, then you can no longer solve. Okay, something like that. Okay, so going back. So in here, class, we will use Q is equals to NCV delta T. Okay, why? Because the volume is constant. Say, volume is constant. If the volume is constant, so the change in volume is not relevant, negligible. So delta V is equals to 0. This one. Okay. Now, work is equals to pressure times the change in volume. Okay, pressure times the change in volume. Substitute the value of 0 in this equation, then automatically our work will become 0. Okay, work will become 0. Then, in first law of thermodynamics, Q will be equal directly to the change of internal energy. What does this mean? Interpret this. Q is equal to delta U in English statement. As I told you, it's not enough to see this quantity. You should express that in a statement, okay, so that you can have a comprehensive learning through the relationship. Meaning to say that the total heat energy of the system is totally converted to the internal energy, or completely used up to the internal energy, used up completely as an internal energy. That's the statement of this equation. Q is equal to delta U. So that's it. So if we have an answer for this, then that is also our internal energy. Just because we are saying Q is equal to delta U. Okay. Substitute values. Now, okay, like that. Okay. So delta T nato is final temperature is, it's here 300 Kelvin. Okay. 300 Kelvin minus initial temperature is 298 pila class. Okay, calculator please. Like this. Okay, it's very easy. Even though elementary student can answer 300 minus 298, but I have still to use the calculator because my brain cells are much higher. Okay, where is that? Oh my gosh. Okay. Andiyan ba kayo? Hello? Are you still there? Okay. You are still there? Please be patient. Okay. So we have 2 na lang siya. 300 Kelvin minus 298 Kelvin is equals to 2. Right? 2 Kelvin. Oh my goodness. Okay. Now, what is our CV to be used? Okay, CV. Guys, actually, guys, we have a lot of specific heat capacity. But the problem here, guys, we cannot assume that this is a water. This is a gas. We can never use the latent heat of vaporization. We can never use the latent heat of fusion. We cannot use the latent heat of condensation. And we cannot also use the specific heat capacity of water because this is not water in the first place. Common sense. Okay, so we need to use the specific heat capacity of an ideal gas. This one, CV is equals to 3 over 2 times R, and CP is equals to 5 over 2 times R. Now, guys, you will investigate now. What R shall I use here? Okay, there are 2 units of R. Let's say the other one is 0.08206 liter atmosphere mole Kelvin, right? And we have also the other one, 8.3145, okay, joules mole Kelvin. So which one will we be using here? Okay, let's investigate. Okay, there's no pressure involved here also. So how can we do this on the spot? Okay. My gosh. Okay, since the 0.08206, guys, has up 2 quantities manggod siya, liter then atmosphere. Then how about choosing the joules only? There will be no complications of 2 quantities. So let's assume we will use the 8.3145, okay, joules per mole Kelvin as our universal gas constant, capital R, so that we can multiply that in our CV is equal to 3 halves times R. Okay. Ganon. CV, 3 halves R. Okay. I-multiply na ito siya diretso, 8.3145. Okay? So, ganon. 3 divided by 2 equals to times 8.3145 is equals to 12. Our CV, guys, is 12.47 joules mole Kelvin. Klaro juga siya. Diba? Now, substitute your CV in the equation Q is also NCV delta T. Okay, because CV is like that. So substitute values to the basic math. So Q is equals to, guys, we are very lucky that our 1 mole is being mentioned in the problem here. 1 mole of ideal gas X. So substitute the 1 mole. Okay. Okay, 1 mole. Okay, times CV, 12.47 joules mole Kelvin. Okay, times the 2 Kelvin, sorry. Cancel, 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 cancel. So joules. Our heat energy here is joules. Okay, heat energy. Because sometimes, class, heat energy can be expressed also in joules per mole. Okay, but that is actually a molar heat energy. Okay, and if it is expressed in joules per kilogram, that is also a specific heat energy. Put that in your brain cells that if we have a word specific before the energy word, For example, internal energy, heat energy, enthalpy. That means there is a kilogram in the denominator automatically without question. Okay, this is a hint. Okay, if it is a molar heat energy, molar internal energy, molar enthalpy, the joules will have a mole in the denominator. Because sometimes the questions in the examination will not specify that it is a molar heat energy, molar internal energy. So, and then you are used to the formula Q is equals to mc delta, and there's no mass. And there's no reaction here also. If there's a chemical reaction, we can compute for the molar mass. Okay, but there's no chemical reaction here. So you will result to the number of mole. Sometimes other students will not use this MCP delta T. If they see that there is no mass because there's one mole, they will try to use the another gases in Dalton's law of partial pressure, ganon, Pascal's law, Boyle's law, Charles' law, combined gas law, Henry's law. There's a lot of gases law, the Van der Waals equation, right? So they will try also to use because of this word here are not compatible to the heat energy that they are memorizing for. Okay, because in the normal bunog na equation, Q is equals to MCP delta T reduce siya. Pero sa PV and RT, bunog ka siya nga equation. Kung sa singing contest, this is a singing piece that always usually sung in amateur singing contest or in talent search. Common, very common, used all the time. Okay, so that's why the questions in the board examination are not really that common. They want it to be unique and distinct. Okay, so that it measures the comprehension, mental ability of the examinees. Okay, just like that. Okay, it will never be directly substitution, or it will never be directly word for word. It leads you to think really technically what's that all about. Okay, sometimes you feel that it's a direct substitution, but then when you see the choices, it's not there. Okay, so that's a simple, analysis for the situation. Charot. Okay, times 9. So 12.47 times 2 times 1 is equals to 24.94 ang atong heat energy. Wow. So 24.94 joules. Oh, ganon. So our heating 1 mole of monoatomic ideal gas at a constant volume from 298 Kelvin to 300 Kelvin. Determine the heat absorbed to the system and how much change in internal energy. This is equal only based on our scientific assumption. So meaning to say the change in internal energy. And that is the correct answer. Okay? This one. Okay, it's very clear. To be honest, class, some of my content in my vlogging, in my live streaming, is just now I discovered when I'm already a registered chemical engineer. But when I was in college, I didn't find some, important theories. I have already that stock knowledge, but it's not so many pa. Now, when I do a lot of research, I found out, oh, sayon pala siya. Okay, if I know this before, I don't know. Oh my gosh. I'm feeling it to be like that, okay? So thank you so much for listening this live stream. If you did not subscribe my channel yet, then you can subscribe now if you want. And then you can comment also anything in the comment section if you want. And also you can also share this to other persons if you want. Okay, but if you like to click the notification bell for some news updates of I Am a Singer Eternal Voice, then you can. Okay, depends on you. Okay, and thank you so much. God bless. Bye bye, everybody. See you later for another problems.